right. So let's go ahead and take notes. We got into graphing. Mr. Metter kind of walked you through graphing a line with an inequality. So if you have a line and you have x is greater than or equal to 5, you would have a closed circle at 5 and everything to the right. That would be kind of how you graph that. So you guys kind of went over that. And then we talked, or Mr. Metter talked about the XY coordinate plane. Okay. Has 4 quadrants. And in quadrant 1, your X number is always positive and your Y number is always positive. And then, of course, quadrant 2, X is negative, Y is positive. Quadrant 3, X is negative, Y is negative. And in quadrant 4, X is positive, Y is negative. And so when you plot points, just like you plot it on an XY, you do X is equal to 5. You would be right there. And up and down, if you had Y is equal to 7, you would have a mark at 7. Now, when we put this Y-axis with the X-axis, this one's the X, this one's the Y. When you have X is equal to 5 and Y is equal to 7, X, you come out here to the 5, and then Y, you go up to the 7. Okay. So that would have been kind of what you went over with Mr. Metter. When we have, so rather than just a regular line where you have like X is equal to 3 and you just fill in one dot, we have two numbers, the X number and the Y number. And so you go over to the X number, that's 5. Then you go up to the Y number, that's 7. Okay. So now what I'm going to do, let's draw another graph. So let's put this in your notes. We're going to do point 8, 9. And we're also going to do point -7, -3. Okay. So the first point, actually 9, 8. So the first point that we're going to put a point at is going to be the point 9, 8. The second point that we're going to do is going to be -7, -3. Okay. So when you have 2 points like this, and if you already know how to put that on your paper, go ahead and graph it. When you have 2 points like this is known as an ordered pair. Okay. Now, when we're doing an XY coordinate plane, it's okay to write them like this. What you're used to seeing, if I were to write something like 9, 8, you're used to seeing the number 8 and 9, and then open circles at 8 and 9, and everything in between them. If you remember from the very first class that we had, we kind of talked about how to do the different types of parentheses. So there was open parentheses, closed, and then you kind of had the curly brackets, okay? This is different because we're dealing with a plane. Okay, in each one of these, you're dealing only in one dimension. And so it's important that we understand that in this case, we're dealing with a plane, okay? So let's graph 9, 8. The first number is my x number, so I go over here to 9. My second number is my 8, so I come up here to 8. And this is my point. 8 over on x, I'm sorry, 9 over on x, 8 up on y. The next one is -7, -3. We always start with the x, so we go -7, and then on the y, we're going down -3. Right there. That is -7, -3. Now what I'm going to do is I'm going to take a straight edge, which I don't have my ruler here, but do have my lab notebook, so we can use that. And we're going to go between, we're going to draw a line between these 2 points, okay? All right. So there's my line. The line between those 2 points. You'll notice that those 2 points now have created a line. Okay. Now what we can do is we can find something called the slope. And the slope in algebra is always denoted by the letter m. Okay? The slope is always the letter m. So what is the slope? Well, the slope is just like if you were to go outside and look at your roof, and let's say you were to compare it to your neighbor's roof or a different roof in a different neighborhood, you would have different roof slopes. And for roofs, they're often called pitch. So you have kind of an A-frame, really tall pitch like that. Those aren't as common anymore. Most of them kind of look like this, but you have some of them that are real flat. You have some of them that are up, flat, and down. Okay. But basically, we're looking at how steep are these slopes. So if you had on your roof something like this, that might be easy to walk on. If you have something like this, that would be tremendously difficult to walk on, right? And so this is steeper, obviously, than this is. So when we talk about slope, the bigger the number, the more it slopes. But how do we calculate what is the slope of this line? Slope is defined. So slope, which is your m, that's defined as what's called the rise over the run. Okay? Make sure this is in your notes. The rise over the run. So the way that we find the rise over the run is we start at one of the points, and then we calculate how far do we have to go up, and then how far do we have to go over. Okay? Up, over. Okay? The x-axis, that's going to be your run axis. The y-axis, up and down, that's going to be your rise axis. Okay? So I'm going to show you how to do this. To go from this point to this point, we have to know how far we have to go up. Okay? So the way that I figure that out is we know that this point here is 8, right, on the y-axis. And if I were to kind of extend that out, we could see how far up we have to go here, right? our rise over our run is going to be this rise and this run. To go from this point to this point, we're going to have to go up so many and over so many. Okay? And as long as we know what those numbers are, then that fraction, that ratio, that is our slope. So let's look here at the first one. Well, we know that this is -3 here. Okay. So we know that we're going to go up 3 here to get to the 0. And then we know from here to here is 8. Okay. Now, if I had graph paper, then I would have a -2, a -1, 0. Then I'd have a 1, 2, 3, 4, 5, 6, 7, 8. So I could literally count them. This would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's the thing. If I go up 3 here, then I go up another 8. That's 11. So my rise to go from this point to this point, I have to go up 11. So my slope, the first part of it anyway, is 11 for the rise. Now I'm going to figure out the run. Okay. So from here, I have to go over. We've gone up. Now we need to go over. So how many am I going over? Well, I know that this right here, right, this was -7 over here. That's so the distance or the absolute value of -7. Remember, absolute value means distance from the origin. So what is this distance? That distance is 7. Then we have this distance here. That's just to get from this point to the y-axis. But then I have to get from here to here to get to my point. And that is 9 units from here. So from here to here is 9. So I'm going to go up 3, then 8. That's 11. Then I'm going to go over 7 plus 9, which is 16. So my run is 16. So my slope is 11 over 16. I go up 11 over 16. You can also say that you go over 16 and up 11. Okay, we can create a rectangle there where the side is 16 and up and down is 11. So to go from here to here, I go over 16, up 11 over 16. Okay? And that is my slope, 11 over 16. Any questions on that? You guys can throw in a question mark if you have one. All right. The next thing I want to show you is you can calculate the slope from just the 2 points. Okay? And the way that we do that is the slope is equal to rise. Well, how do I calculate rise? Rise is going to be this distance here, which is the difference between +8 and -3. +8 and -3. So what it is, it's 8 minus -3, or the y component of the point. We'll call this point number 2, this point number 1, this is point 1, this is point 2. So point 2, the y component of point 2 minus the y component of point 1. I'm going to change colors there because that one's kind of running out of ink. So the y component of point 2 minus the y component of point 1 over the x component of point 2 minus the x component of point 1. What do I mean by y component and x component? So remember, each ordered pair has an x and a y, right? Something for the x-axis and the y-axis. So the 0.57 on this graph, 5 is the x component, because that's how far you go over on the x-axis. 7 is the y component. That's how far up or down you're going on the y-axis. So for 2 points like this, you have 2 y components and you have 2 x components. So we're going to call this one down here the -7, -3 point. That is 0.1. And then the 9, 8 point up here, that is 0.2. So the 9 is my x2 component right there. The 8 is my y2 component right there. This -7, that's my x1 component. And the -3, that's my y1 component. All right, so now this is my equation. The slope is equal to y2 minus y1, that quantity, divided by the quantity x2 minus x1. So now let's fill that in. Y2 is 8 minus y1. First point, the y component. That's a -3. And now x2, here's my second point. X component is 9 minus x1. Here's my first component. I'm sorry, the first point, the x component is -7. All right, so I have 8 minus -3 over 9 minus -7. So what does that give me? 8 minus -3 is 11. And over 9 minus -7, well, that's 9 plus 7, or 16. So you see how we got to the same number, 11 over 16. So we can do it visually. We can also calculate it. Okay? Make sure all of that's in your notes. I'll leave it up here for just a second, let you finish copying. You can also just grab your screen, file that away. All right. So now, let's look at the equation. Y is equal to 2/3 x plus, or we'll say 2/3 x minus 2. All right. So what are we going to do? We're going to graph this equation. Now, what we did before is I gave you 2 points and we drew a line between them. All right. For every line on your paper that you could come up with, however you drew a line, there exists an equation that describes that line. Okay? So real quick, let me kind of show you this. if we have one point out in space, there, that's described by an ordered pair, okay? An x1 and a y1. But a line, okay, like this, that's made up of an infinite amount of ordered pairs, x3, y3, so on and so forth. There are an infinite amount of dots all through here that all connect to form this line. Okay? If I were to put a dot out here, this is a point, but that point does not exist on this line. If I were to put a point here, or a point there, or even really, really close, but still not there, all of those points do not exist on this line. And what we can do is every line can be described by an equation. So what I'm going to do is here's the equation, and we're going to plot it. Plotting simply means that we're going to draw it on this graph. So the way that we do that is we make what's called an X and Y chart. And we're going to plug in any number we want for X and see what it gives us for Y. Okay? So I'm going to choose 0 for X. Okay, so if I choose 0 for X, this is going to be Y is equal to 2 over 3. My X is going to be 0. So times 0 minus 2. 2 over 3 times 0 is going to be 0 minus 2. 0 minus 2 is negative 2. So if I plug in 0 for X, my Y becomes negative 2. So that's my first point. 0 for X, and then on the Y, I get negative 2. So I'm going to put a point right there. All right. Then I'm going to put in 0 for Y. See what I get for X. And I like using zeros because they usually make things easier. So we have 2 over 3 times X. I don't know what X is this time because I'm substituting the 0 in for Y, minus 2. All right, I'm going to add 2 to both sides. So I have 2 is equal to 2 divided by 3x. All right, so I'm going to divide both sides by 2/3. And I have x is equal to 2 divided by 2/3, or 2 times the reciprocal of the bottom, which would be 3 over 2. The 2's cancel. X is equal to 3. So if x is equal to 3, y is 0. So if I go over to 3 on x, 1, 2, 3, then the y is 0. All right, so let me go ahead and draw my line there. I've got 2 points. So between any 2 points, I can make a line. All right. So this is the line that this equation right here is describing. What that means is if I go over here to 4, 5, 6, let's say 7, okay? If I go over here to 7, there exists a number right here that is going to be on the y-axis, okay? So let's plug in 7 for x. This is my x-axis. So the 7 for x, we're going to see what y it gives me, okay? So y is equal to 2 over 3 times 7, and then minus 2. All right. All right. 2 times 7 is 14. So I have 14 over 3 minus 2. All right, I want common denominators, so I'm going to change this to a 2 over 1 and multiply the top and the bottom of that by 3. So y is equal to 14 over 3 minus 6 over 3. And that gives me, minus 4 gives me 10, minus 2 more gives me 8. So 8 over 3. All right, so I'm going to change that to a mixed number so I can kind of see between what whole numbers I'm at. So 8 over 3, that is the same thing. 2 3's going to 8, so I know I have at least 2 whole numbers. And that gives me 6. And I have 2/3 left over. So I have 6/3 gives me 2, and then I have 2 more thirds. So 2 and 2/3. So here would be 1, 2. 3 would be up here, so 2, and this would be 2/3. Obviously, the way I'm drawing it, is not accurate. If we were on graph paper, it would be accurate. But here's your 7, and then over here would be 2 and 2/3. And really, my point only is that if I plug in any number, even if I come over here, -3 would give me some number down here. Okay. But let's figure out the slope. And we'll just use these two numbers right here. Let's figure out the slope of this line. And remember, the slope, m, that's equal to the rise over the run. The rise over the run. So if we start here, I am going to have to go up 2 units and over 3 units. Up 2 over 3. So my rise is 2 and my run is 3. So the slope of this line is 2/3. Now, if I were to use the equation, all right, y2 minus y1 over x2 minus x1. What's this first point here? That is 0, -2. And the second point here is 3, 0. All right. So if I plug those in, label these my first point and my second point. All right. So my second point y coordinate, that's 0, minus my first point y coordinate, -2, divided by my second point x coordinate, that's 3, minus my first point x coordinate, that's 0. 0 minus -2 is 0 plus 2, or just 2. 3 minus 0 is 3. 2/3 is my slope. Very good. Now you'll notice in our original equation, we see a 2/3 right here. And that's not just a coincidence. That is because the form of this line is called slope intercept. This is something you'll need to write down. Slope intercept form. All right, slope intercept form. Okay. And the way that that form takes is in the form of y is equal to m, which is the slope, times x plus b. Okay? So make sure in your notes you have slope-intercept form, and then you have y is equal to mx plus b. So if we look here, the slope is 2/3. So we have y in our equation is equal to the slope times x. There's my x, and then plus b. But I have a minus 2. What is b? We know that m is the slope. B is the what's called the y-intercept. The y-intercept. Okay, what is the y-intercept? The y-intercept is where the line crosses the y-axis. Okay, here's the y-axis. Where does this line cross? It crosses right here at the point 0, -2. Now, no matter what, for every point in the, any line in the universe, no matter which direction the line is going, no matter where the line is, there's always going to be a point at which it crosses over the y-axis. And at that point, no matter where it is, the x component will always be 0. The y component will be the number that it crosses. So in our case, it crosses here at -2. So b would be -2. It's the y component of where it crosses the y-axis. So here, our b for this line would be -2. So y is equal to, I calculated my slope, 2/3 times x plus my b is -2. And if I do x plus a negative, that's the same thing as just subtraction. So you can see that this equation that we started with is the slope-intercept form. Okay? Any questions on that? That was a lot of information, especially on one page. All right, good. So what I'm going to do now, let me double check, make sure I get to all the points. All right, so let me show you on I'm going to show you on graph paper. So I'm going to share my screen here. So make sure that you can see. Okay. All right. Now I'm going to put in our line that we just came up with. That was 2/3 x minus 2. All right. So over here, you can see that it crosses the y-axis at 0, -2. And then the other point that we calculated, 3, 0, that's where it crosses the x-axis. And you can remember that we also did 7. So if we come over here to 7, we should be at 2 2/3. So that's about, it's not exact. Let me see if I can get it right on there exactly. Almost, there we go. 7 and then 2.666 repeating, but they rounded the last 6 to 7. All right, 0.666 repeating, that's 2/3. So here we have 7 2/3. So that was exactly like all the points that we had. We had 0, -2, 3, 0, and 7 and 2 2/3. All right. Good. All right. Somebody asked why round the last number. And that's because 2 over 3 is 0.666 and it just repeats forever. So obviously in a computer, when you show that number, you can only show so many digits. So no matter where you cut it off, if I cut it off right here, for example, the next number is 6, which means that this has to round to 6667. All right. So I'm going to do another line. Y is equal to, and we're going to do 2/3 x plus 4. Okay. Let me zoom out a little bit here. All right. What do we notice about these two lines? We have a red one and a blue one. These two lines are what we call parallel lines. All right. Parallel lines are lines that have the same slope. So if we look at the equation of these two lines, and I'm also writing on my screen, so make sure you can see both. Parallel lines means that the slope from one equation is equal to the slope from another equation. So look at these two equations. Y is equal to 2 over 3x minus 2, and y is equal to 2 over 3x plus 4. So they're both in y-intercept form, and we can see that they both have a slope of 2 over 3. So because the slopes are the same, we know that they are parallel lines. What's different about the two equations is the y-intercept. One is going to intercept at -2. That's this red one right here. And one of them is going to intercept at +4. All right. Now I'm going to do a third line, and I'm going to show you what a line perpendicular to this looks like. Okay. All right. That green line, the third one there, is a perpendicular line. What does perpendicular mean? It means that the green line and the blue line make a 90-degree corner. The green line and the red line make a 90-degree corner. Look at the slopes between those. The two parallel lines have the same slope, 2 over 3. The perpendicular line is opposite and the reciprocal. So notice the parallel lines are +2 over 3. The perpendicular line, though, is negative. So it is opposite of the slope, and it's the reciprocal. Instead of 2 over 3, it's 3 over 2. -3 over 2. That makes it a perpendicular line. And you can see that right there. This green line is perpendicular to it. We also see that it's in slope-intercept form. The slope of this line is -3 over 2, and it crosses the y-axis at -8. So that's down here, and you can see that. 0, -8. Okay. All right, so what happens if you have something that is not in slope-intercept form? Okay, we have something like this. 2x plus 3y is equal to 6. Your temptation is to say, oh, well, that's the slope right there, 2. 2 over 1. Rise of 2, and we're over 1. But that's actually not true. In order to find our slope, we have to do some algebra, and we have to solve for y. So just like before, when we were solving for x. Now we have to solve for y. Okay, but we have two different variables. Okay, so I can't combine the 2x and the 3y because they are not like terms. But I do want to get the 3y by itself. So what I'm going to do is I'm going to subtract the 2x from both sides. So I have 3y is equal to 6 minus 2x. Okay? Then I'm going to divide both sides by 3. And the 3 over 3 here cancels. And I'm left with y is equal to 6 minus 2x over 3. Now what you'll notice is that doesn't look like slope-intercept form. Slope-intercept form is supposed to look like this. Y is equal to mx plus b. So I have to do some rearranging. So remember that when I have a couple of terms here in the numerator and I have a denominator, that means that they had a common denominator. So if I had 2 over 3 plus 5 over 3, right, I can add the numerators. 2 plus 5 over 3, or 7 over 3, because they have a common denominator. So this 2 plus 5 over 3, I can split that back to 2 over 3 plus 5 over 3. And I'm going to use that same idea here. I have 6 minus 2x all over 3. I can't combine the 6 and the negative 2x, but I can split each term over the denominator. So I can have 6 over 3 minus 2x over 3. And why? Because they have a common denominator, which means I can add the top over one denominator. So I'm kind of working backwards from the common denominator. Okay. Now I've got 6 divided by 3. Well, that's just 2 minus 2/3 x. Okay. You'll notice it's still not in the proper form. And I'll leave the x in the numerator so I can kind of talk about that too. Okay. So this is where using the definition of subtraction comes in handy, because I just can't flip these two because I can't subtract anything in any order I want, but I can add them. So this then can become 2 plus negative 2x over 3. Now I can switch them. So I have negative 2x over 3 plus 2. All right. So y is equal to negative 2x over 3 plus 2. All right, we're about there, right? Y is equal to slope times x plus b. All right, so is this the same thing? Negative 2 times x over 3, is that the same thing as negative 2 over 3 times x? And it is. This is the same thing. And how do I know that? Because this x by itself can also be x over 1. And if I multiply the numerators together, that's negative 2 times x and 3 times 1. You're right back to this. Now we want to write it like this because that puts us in the slope-intercept form. We have y is equal to negative 2/3, that's my slope, times x, plus b. I have a positive 2 for my y-intercept. Okay? So now that I've got this in slope-intercept form, I'm going to look at my original equation. My original equation was this. Well, negative 2/3 does not show up in that equation. So we have to solve for y in order to find the slope. The other thing that we could do is we could plug in values for x, find out what y is, get 2 points, and find the slope that way. All right, something else I kind of want to bring up. -2/3 is the same thing as +2/3, which is the same thing as the negative out front and 2/3. All those are the same, okay? And the reason is if I have 2 points, well, let's say I have a point right here, and I'm going to do a rise of -2. So let's say this is going to go down 2, okay? -2. I'm going to drop 2, and then I'm going to go over a +3. All right. 1, 2, 3. 1, 2, 3. So I'm going to go over 3. So I'm going to go down 2 over 3. Okay. This would be my line right there. All right. Here are 2 points that the rise would be -2, +3. Now, what if we did -3 and +2? Well, if we start here and we did +2, so we went up 2 instead, and then we did -3. We went this way 3. We would still be on that line. So even if we go the other way, even if you make it +2, -3, or -2, +3, it's still going to be points that exist on that line. So you're okay. But let me just do this one concept. If I have y greater than, okay, then you have 2/3 x plus 2. Sorry, 2/3 x plus 2. In fact, let me share my screen, and I'll graph that for you so you can kind of see what that looks like on the screen, because that'll be better than me drawing it. All right. So let me do, I'm going to have y is greater than 2/3 x plus 2. All right. So this looks kind of different. Okay. Now you guys have done greater than or equal to and greater than, if I had x is less than 3, so you're here at 3, or sorry, 1, 2, 3, and it's an open circle, right? Not shade in. Open circle, x is less than, so it's everything to the left. Okay, that open circle, that's what the dashed line here that you're seeing, this black dashed line. Notice that that line right there, that has a slope of 2/3 x, and then it crosses the y-axis here at 2, so it behaves just like a normal line. It's completely parallel to your blue and your red line. Okay, but it's dashed because instead of an equal sign or a greater than equal sign, it's just a greater than. So that's why it's dashed. Okay. The other thing you'll notice is it's completely shaded up here. Okay, because it can be any number greater than. So what you do after you've drawn the line is you pick a number up here or down here. So I would pick 0, 0. That's a number down here that's easy to plug in. So if I plugged in 0 and 0, is this true? Well, let's see. Y is greater than 2/3 times 0 plus 2. 2/3 times 0 is 0. Y is greater than +2. But we plugged in 0, 0, so we made y a 0 as well. Okay. Is 0 greater than 2? It is not. That is a false statement. 0 is not greater than 2. So what that means is 0 does not exist as an answer. So you shade the opposite side. You shade this side right here because everything over here is an answer. All right. I hope that was helpful. You guys have a great evening.